Reality as law. Newton's conception of reality is our starting point. His conception of reality is the first truly scientific portrait of existence. It has become our modern world picture of what reality is. This is why it is important for us to understand the elements of Newton's physical reality. Understanding his view of the world makes it possible to understand the changes that physics has undergone in the 20th century. Only in this way can we grasp the strange reality of the new physics. Newton then will provide us with the foundation we need for our work. Newton stated that there are 3 laws of motion. It is not important for us to study these laws, but let us at least state them. Newton's first law of motion states that if an object is left alone, it will continue undisturbed, either remaining at rest or continuing to move along in a straight line with uniform motion. In the absence of any force acting to cause a change in the motion of an object, the object maintains its state of motion. This principle, known as inertia, is now recognized as holding everywhere and for all things. By means of this simple statement, Newton dismissed mankind's accumulation of nymphs, spirits, demons, ghosts, goblins, and gods. Newton's second law tells how a force alters the motion of a body. A force applied to a body will cause a change in the momentum of the body. Here Newton made it clear that momentum is something quite specific. It is the product of 2 numbers, the mass of the object and its velocity. The greater the mass, the greater the momentum. Obviously, a freight train going 10 miles per hour will not be stopped if I sprint headlong into the thing. Its greater mass gives it greater momentum. Similarly, a baseball bat swung full tilt will produce a greater effect than when it is used to bunt. Its greater velocity gives it greater momentum. Both the mass and the speed determine the momentum of an object. But Newton's second law of motion is more specific. It tells us precisely how the force will change an object's motion. It says that the effect of a force acting on a body is exactly given by the rate at which the momentum of the body increases with time. The precision of this law has led to the precision that has made physics such an exact philosophy. The precision of Newton's statement lets us determine the nature of matter in ever-increasing detail. Newton's second law is perhaps the most powerful statement ever uttered, for it has changed man's earth more than it has moved us closer to a precise knowledge of physical reality than any other single statement. The third law of motion says, to every action there is always opposed and equal reaction, or the mutual action of 2 bodies upon each other are always equal and directed to contrary parts. That is, anytime 2 bodies collide, each exerts a force on the other. The force exerted by one of these bodies on the second has exactly the same magnitude at every instant as the force exerted by the second body on the first, except, of course, these forces act in exactly the opposite directions. Moreover, this equal and opposite force principle also holds true any time that 2 bodies act on each other, whether in a collision, through friction, via gravitational attraction, or by any other means. These then are Newton's 3 laws of motion. To these, Newton added his law of universal gravitation, which specifies that every body in the universe exerts a force on every other body. This force depends proportionately on the masses of the bodies and falls off as the square of the distance separating them. The reason for selecting such a hypothesis for the way the force of gravitation works is simple. Obviously, the larger the object, the stronger its force of gravitation. The Earth surely has a greater pull on me than an apple has. The gravitational pull must depend on how much mass there is. If it didn't, the force on a heavy body would not be proportionately greater than the force on a light body, and Galileo's famous experiment at the Leaning Tower of Pisa, where he dropped objects of differing densities to show that they fall at the same speed, just would not have turned out the way it did. So the gravitational force of the Earth on me has to depend on how much material, how much mass there is in my body, and it also has to depend on the mass of the Earth. I pull on the Earth with exactly the same force with which the Earth pulls on me. The relationship is symmetrical. The force of the Earth on me and my body's gravitational pull on the Earth are identical. This is just Newton's third law, telling us again that objects exert equal and opposite force on each other. Newton discerned that the gravitational force falls off with the square of the distance by noting that this is how the apparent size of an object falls off with distance. He astutely observed that this may be how distance dilutes the force of gravitation of such very massive but very distant objects as the sun, the planets, and the stars. But our purpose is not to discuss Newton's mechanics in such detail. What I want to point out are the main features of this picture of reality, which will serve as our point of departure. Newton's understanding either has been the basis of or has strongly colored all modern scientific, philosophical, and even theological efforts to represent reality. This classical picture of reality that he gave us had to be there in Newton's mind before he stated any of his laws of motion. Indeed, his laws of motion are the product of his clear understanding of the nature of reality. Newton's picture of reality presumes the following three basic ideas. First of all, it is clear that Newton's laws presume that the condition of an object can be given by specifying the object's location, its speed, and direction of motion, the forces acting on it, and certain characteristics of the object, such as its mass. To put this differently, Newton's laws give us a picture consisting of objects, each of which has a specific state. The object is not possessed by any spirits. Its nature does not change depending on the will of some capricious god. Each object has one innate position, one speed, and one constant mass. Second, Newton describes a deterministic universe, a universe in which every effect has a specific cause, and each distinct cause produces one distinct effect. Objects that are left alone stay at rest, if initially at rest, or stay in steady motion in an undisturbed straight line, if initially in motion. Only when a force acts on the body does the body change its motion, and its response to that force is immediate and absolutely specific. Third, Newton's philosophy describes the world in entirely objective terms. The world is real and consists of discrete objects. There is no place for mind, consciousness, or will. There is no place for a soul to survive, no place for God. This last statement would have rankled Isaac. He was a devout believer in God. But the philosophy Newton created has led us elsewhere. It is a picture of reality populated only by pieces of matter that differ simply in shape, mass, location, and motion. The universe is made of non-sentient objects that change according to three exact laws of motion. Light, too, in Newton's conception, consists of tiny pieces of matter. The rainbow of colors that enliven the world around us simply reflects the differences in the sizes of the different grains of light and the way in which those corpuscles bounce off of or are absorbed by the porous surfaces of objects. Newton's picture of the world contains forces, but he removed the distinctions of the vis viva and vis morter, the animate and inanimate forces, and banished as superstition the supernatural forces lurking behind shadows that jump in the night. His mechanics showed that all forces, whatever their origin, have one effect: to accelerate the body they act on, and one cause, one origin, the presence of other objects that are otherwise inert except for their mechanical properties. Yet for Newton and for most of the scientists of his time, reality also had another dimension. They believed there was, in addition to and removed from material objects, a hidden agency, an omniscience, an omnipotence, a personality that existed as creator and first cause. For Newton, human souls existed as real things, but Newton's success was greater than even he would ever have imagined. His philosophy paired out the possibility that a deity or a human soul could play any role in the world. After Newton, natural philosophy passed by the questions of God and of the human soul. Thus, even though Newton saw things differently, and even though this was never his own intention, the elements of deity and soul must be omitted from the scientific picture Newton produced. The scientists of Newton's time did not presume that their paradigm was adequate to deal with all aspects of reality, nor to fill the robes of God. The conditional stipulation of a supernatural order was still an essential proviso of philosophic thinking at that time. For Newton and the scientists of his time, God had set up the universe and set it in motion. Newton's laws simply governed the running of the universe. That is how Newton saw the workings of God and the workings of God's universe. Newton's belief in a personal God has been abrogated by the very success of his mechanics. His laws of motion have worked so well that this philosophy has pushed back the unknown frontier where once St. Paul's unknown God could hide. By the end of the 19th century, scientists had constructed a picture of the universe that could be thought of as very nearly complete and self-consistent. The scientific picture of reality, fleshed out during the 2 centuries following Newton's Principia, added thermodynamics and Boltzmann's statistical mechanics. With these tools, based on Newton's mechanics, physics could reach down into the molecular and atomic world. Newton's laws could explain the behavior of matter at work in steam and combustion engines, and could account for fire, heat, and the thermal properties of matter. By the end of the 19th century, physics had added Clerk-Maxwell's electromagnetic theory, embracing the diverse phenomena and forces of electricity and magnetism. Now physics could explain the detailed nature of light and reach far beyond Newton's own achievements to measure the distances to the stars. With a basic knowledge of chemistry and the synthesis of a few organic compounds, science could conceive of a chemical basis of life. With Darwin's handy adaptation of Wallace's theory of evolution, even the origins of life could be tentatively tracked back into the dim beginnings of time. By the end of the 19th century, science had put into place a comprehensive materialistic philosophy of reality. Toward the end of this classical period of physics, the whole world seemed to fit so well into these few simple laws that physicists could boast that the future of physics lay only in the next decimal place. There seemed to be nothing fundamentally new left to be discovered. There existed only the task of further detailing this perfect philosophy. In its proudest moment, classical physics could look upon nearly everything one could see with an imagined total comprehension. In this view, the universe consists of matter made of elements with orderly properties. In combinations, these elements form all the materials of every object in the universe, including our own bodies. The heavens are filled with stars like our own under the force of universal gravitation, according to Newton's laws. Light is understood to be a wave of electromagnetic energy. Its speed through space can be calculated from theoretical principles. The knowledge of the working of the world coming out of Newton's philosophy spawned the machines of the new technologies. Electric motors, telephones, electric lights, electric generators, telegraph, and radio. Electric forces acting between atoms accounted for chemical reactions that released the heat to drive gasoline engines or produce the steam of the great locomotives and ships of war. The age of the secular, technological city, the world we live in today, was created by this philosophy. It shapes what we think and believe to be reality. All of this wonderful, terrible creation began in the mind of Isaac Newton.